Our topic today is transformation. The simple meanings of this topic for this transformation is the change of the figure from one place to the other. That means either the size will be changed, or the shape will be changed, or the area will be changed. So this topic is known as to be called transformation. We know that we can divide it into the two categories for this topic of transformation, which is the change of the figure. That means it can be either isometric or other thing is known as to be called non-isometric. Iso means same. So when the measurements are same, then it is known as to be called isometric transformation. And this, we have three categories. One is known as to be called reflection. Other is known as to be called translation. And the third is known as to be called rotation. And in the non-isometric, because the word is there, non, so that means what the measurements are not same. Here we can say that the real is equivalent to image. So here we can say that the real figure is given to you, then you apply the transformation properties. And you get the image. So the real is exactly same as size, shape, and area, then that is known as to be called isometric. Then there is non-isometric, which means measurements are not same. So it will be having a topic of enlargement. It will be having a topic of shear, and it will be having a topic of stretch. Here, real is not congruent to image. But in our AS syllabus, as far as this topic of transformation is concerned, we have the reflection, the translation, and the stretching. So these are the three topics we are going to discuss one by one in the case of this topic of transformation. First of all, if it is reflection, then it can be either due to x-axis or y-axis there. Suppose we have a general equation as y equal to f of x, and then we have the transformation like y is equal to minus f of x, then it is the reflection. And we will categorize this that if P point is xy, then P dash will become x and minus y. So this means it is the reflection due to x-axis. For this, we can give an example that if y is equal to x square is this original figure, and now we want to draw the graph of y equal to minus f of x. So this minus sign is outside the function. So it is the reflection of this figure about x-axis there. So it means xy will be changed in the form of x and minus y. So this means x coordinate remains same and the y coordinates are going to change the shape. And all positive values of y will become all negative values of y for this case there. Again, if y is equal to f of x, and now you have the draw of y is equal to f of minus x, then it is the reflection due to y-axis. Or in other words, simple words, if P point is xy, then P dash will become minus x and y. This means all x coordinate will be changed and the y coordinate remains same. For this figure, it's, let's say, this is the equation of y is equal to x of f of x. Then we can have this image of this x will be changed and y will be in same. So this is the image of this due to y-axis there. So it is a reflection of this P dash figure, whereas this is P, which is x, y, and this is P dash, where x is minus and y is as it is there. So it is basically the reflection due to y-axis there. Then we have the next topic of this part, and that is known as to be called translation. Again, this translation topic is divided into two parts, one due to x-axis and one due to y-axis. If the point P is xy, and that is going to be transformed to the new figure there with P dash, and its coordinates will be x plus a and y, then it is the left translation on x-axis. That means the whole graph is a units shifted towards the left side of this part. For example, y is equal to f of x is sine of x. We know that this is the graph of sine of x up till 360 and it's 1 and minus 1. Now we have to draw the graph of y is equal to sine of x plus 30. So this means this original graph of f of x is going to be changed to this form with 30 units backward to that. So the graph of this function will be like this. Instead of ending at 360, now it will end at 330, and this is minus 30. So the whole graph is 30 units backward to that on the x-axis there. And if we have to make the matrix of this part, so the matrix of this is denoted by M there, and it should be equal to minus A and 0 there. So this is the graph for this x-axis there. Now, if we have to draw the graph of on y-axis, then the point P xy, so not on the y-axis, on the x-axis, but it is towards the right side of that. So it should be equal to P dash, it should be x minus a and y there. So this means that if this is the original graph of sine of x, which is equal to f of x, then the graph of f of x minus 30 degree, that means it is going to be shifted 30 units towards the right side, and the graph will be like this. This means 30 units it is moving towards what? The right side. So if it is plus A, then it should be shifted on the left side, and if it is minus A, then it should be shifted on the right side of this graph there. And the matrix for this portion is A and 0 there. So this is the translation on x-axis and the translation on y-axis there. So this is the case when it is translation on the x-axis there, either on the left side when it is plus A and the right side when it is minus A. And now we will do the translation on y-axis there. For the y-axis translation, if the point P is xy, then after transformation, the new point will be x and y plus A, because A units is moving upward there. So this is the translation on y-axis, A units upward. Now, let's say y equal to f of x, and let's say that is the same graph sine of x. And now we draw the graph of sine of x plus 2. So that means the whole graph will be shifted 2 units upward there. So this 0 value will become 2 and 1 value will become 3. So this will be 0 to 3 and 1. So 2 units, this graph is being translated upward there. And if we draw the next graph of this, let's say P point is xy. After transformation, this point will become P dash x and y minus a. So that means it is downward a units. And the matrix for this portion is 0 a there. And for this case now, let's say the sine of x is this graph, which is equal to f of x. Then the graph of y is equal to sine of x minus 2. Then this graph of sine of x will be 2 units downward to that. So here it is 0. So that value will become minus 2. And this 1 will become minus 1. So up till the same 360 degree, it will be minus 1. And this minus 1 will become minus 3. So the whole graph is 2 units downward to this graph there. This is the concept of that a value. If it is added to the y value, then it is translated upward. And if it is subtracted from y value, then it is translated 2 units or a units downward to that graph there. And now the last part of this is the stretching. Stretching is either due to the parallel to x-axis are parallel to y-axis. So these are the two ways of the stretching for every graph there. So first of all, we take the case that if y is equal to f of x and it is being changed to the probability y is equal to f of x plus a, then it means it is having the stretching with the a factor there. So sorry for that. Now it is stretching due to either x-axis or due to y-axis there. So first part is if it is due to x-axis, then we write this thing as y is equal to f of ax. So we have the equation there that if it is xy, then it will be equal to y dash x and x over a and y, where the scale factor is 1 over a there. Then it will be stretching due to x-axis there. Now how it will be, for example, y equal to sine of x, we know that the graph of this is equal to this part. And we have to draw the graph of sine of 2x, where a is 2 there. So the stretch factor for this portion will be equal to 1 over a, and that is equal to 1 over 2. So now we have to draw the graph of this new function y is equal to sine of 2x. Then this means every value of x will be doubled. So up till here, it should be 360, it should be 180, this should be 0, 1 and minus 1. So it means there are two cycles. Here there is one cycle for this portion. And here there are two cycles for this portion, because 2 times it is being stretched on the x-axis towards the right of that portion there. If y is equal to sine of half x, then this graph will be like this. If the graph is like this, sine of 3x, then 3 cycles will be there. So it means the period here is, the stretch factor here is 1 over 3. Our k value, which is the stretch factor, that is equal to 1 over 3. So 3 times it is being there. So this is the way that when we stretch it with respect to the x-axis, then the properties there is y is equal to f of ax. So a is going to multiply it inside the value of x, and then we are going to find out the function value of this portion there. And now we will do the last part of this. So B part is y is equal to a f of x. Now a is multiplied outside this function, and we have to write down this equation. Then pxy is the original coordinates. Then p dash will become x as it is and ay. So y values will be multiple of a there if it is multiplied outside of this function there. And we can have the different values of a, and we have the sketch of this portion for this graph there. Let's say y equal to f of x, and let's say that is equal to x square. Now, for this y equal to 2x square, so that means 2 is multiplied outside of this value of this function. So it means the values of y will be doubled of this value there, because the scale factor is here 2. So if y is equal to x square is this value, then y is equal to 2x square is the graph of this. So it means it is squeezed now, or it is the stretching due to y-axis there. We can have another case, y equal to half x square. So we can draw this graph, y is equal to x square with the dotted lines. If it is y equal to x square, then half x square means it will be like this. It is stretching due to y-axis there outside of this function. So this is the graph of y is equal to half x square. So these are the ways that we are going to do the transformation topic on these three categories. One is the reflection, then it is translation, and then it is the stretching. And reflection on both x and y axis, then translation on both x and y axis, and then the stretching on both x and the y axis there. So these are these properties for this topic of transformation, which we are going to use in this part. And for this matrices of this stretching factor, if it is